And this is one thing that we'll be learning, because this will help us to actually learn the data mining concept more properly. So statistics is the entire process involved in gathering evidence to answer questions about the world, in case where that evidence happens to be the data. So your data is your everything, and you have to use the right data to do a right experimental setup and come up with your conclusion. So that's why it's very important that we learn the basic statistical concepts quite properly. I'm sure that most of you are already aware of those concepts that we asked you guys to read, especially chapter 4 from the book Statistics for Dummies by Ramsey. But the later part, we will be explaining those concepts in a simpler way, so we all actually understand well. Okay, if you recall, in one of the videos, we are discussing about different types of data, like structured data, unstructured data, semi-structured data. But whatever volume of data, whatever modality of data, like image data, or maybe text data, or maybe numerical data, or maybe like social network data, or maybe communication data, whatever data you have, at the end of the day, the computer, as you know, that is a digital electronic machine, it reads the data in the format of binary form, meaning you represent everything into 0 and 1s, right? In terms of statistics, we can categorize most of the data into two categories. One is the numerical data, and the other is categorical data. Numerical data, sometimes known as quantitative data, can be of two types again. One is the measurement data. So for example, your height or weight or blood pressure. So these are measurement data. And they can also be the counts, like for example, how many number of pages the reference book that we are talking about has, how many number of tooth your pet has, So these are counts data. So one is measurement data, the other one is counts data. In another way to see these two types is continuous data, like the height of a person or weight, and also you can say the counts as a discrete data. Discrete meaning that can be counted, right? So these are the examples of numerical data or quantitative data. The other type, what is called qualitative data or categorical data. So categorical data, the name of the days in a week, the name of the months in a year, which country you were born, how many letters your language has. So these are the examples of categorical data. The categorical data again can be two types. One is that ordinal data. So the example of ordinal data is your grades. Like for example, if you have a grade A, and so you are better than those students, they have grade B, and the grade B students are better than grade C. Other type of ordinal data examples are the week of the day. Friday comes after Thursday, and Sunday comes before Monday. So these are ordinal data. And the others are non-ordinal data. For example, your name of the country, your marital status, those are non-ordinal data. Now we'll explain the two concepts. One is the data set and the other one is the variable. So we want to do some experiment or research, so it depends on what data we are using. So let's say In a simple scenario, our experiment is that we want to measure the weights of packages that arrives every day to your office. So let's say today you have 5 packages they came to your office, and their weights are in pounds: 12, 22. The third one is again 22 pound, and the fourth one is 68 pound, and the very last one is 3 pounds. So these are the 5 packages you received. So your data is 12, 22, 22, 68, and 3. So this constitutes your data. You can again define the data in another way, like for example, if we want to use so these are of course count data, that means numerical data, but you can have another definition of the data, that okay, I want to define the packages from 1 to 10 pound as small packages, and then from 11 to 30 medium packages, and more than 30, over 30, those are large packages. So you can see that the same data we can label as medium, 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 because this is medium, this is medium, this is medium, this is large, and this is small. So you see the same data, but the representation is 2 different ways. So these are your data. So it's a data set. Now, what is the variable? So you are having one higher level concept that actually relates to your data. Like for example, here we are saying that okay, these are the weights of the packages. So the weight of the packages can be a variable, and the sequence of package weights are your data. So for the first case, we are saying that weight of packages is my variable, and these are my data. For the second case, we are saying that size of the packets is your variable, and this sequence of packet sizes are your data. Now we'll define population. So population is your focused group of individuals or entities related to your query or research. Say a group of people, cities, animals, and so on. So you can know your population by asking some of your research questions. So let's say we are asking that what do Americans think about the president's foreign policy? So we're talking about the entire American nation, right? So the entire American nation is your population. The second question, what percentage of planted crops in Wisconsin did deer destroy last year? So we're talking about all the plants, all the planted crops in Wisconsin. So this is your population for this research question. The third one, what's the prognosis for breast cancer patients taking a new experimental drug? So we're talking about the breast cancer patients who took this new experimental drug. So we are talking about a subset of people that they have breast cancer, and also they tried a new experimental drug. So these are the examples of your population. Now let's talk about static or statistic. So again, let's go back to the first question, that we want to know the thinking of all the Americans about the president's foreign policy. But we are not going to reach out all the Americans and ask that, okay, what do you think? So we have to choose like some sample of people where we are going to ask, or maybe like do our research on. So we are going to label a sample of people or sample of entities who are linked to our research query, right? So when we summarize the sample with certain numbers, then that number is called static, and the parameter is that when we do for the same for the entire population, or maybe like close to the entirety of the population. So for example, an average household income in West Michigan, is, so we're talking an average of a sample of people, then this is a static, and if you're talking about the entire population, then the static becomes a parameter, So parameter is for the entire population, and static when we actually look some small group of people, or maybe like a small set of. Now comes another term, what is called bias, So bias meaning that we are concluding a research question, but the research was done with a sample of data points, but that are not representative of the entire population. So this is called bias. Bias is a systematic favorism that may present in data collection process, resulting in a misleading conclusion. Let's take an example. So let's say like we have seen the last American election, and this graph is showing the results that where Democrats did good and where the Republicans won. We had a job to actually do a pre-election survey, and let's say like we just took all the samples from one state, Texas. So what that will lead? So our results will lead that the American election will go towards the Republicans. You can also take an example from the other way. Like for example, you only took samples from California, so you'd have more biased results towards the Democrats, right?